My name is Dr. Amirul bin Abu Bakar, a senior lecturer at the Department of Water and Environmental Engineering, School of Civil Engineering, Faculty of Engineering, University Teknologi Malaysia, and I will be your host for this afternoon meeting and sharing session. Okay, before I proceed, just a brief introduction about this program. Okay, this SKA sharing, SKA Shine 2021 meeting and sharing session has been conducted since the previous year, 2020. And this series number 2 is the continuity based on the previous meeting and sharing session. Basically, this session is organized to bring together young senior lecturers from the School of Civil Engineering to share their experience together with all of the faculty members, school members actually, during their services with the university. Okay, that's just a short introduction about the program. Before I proceed with the main lecture series, I would like to invite Professor Dr. Khalida Binti Muda, our Assistant Chair for Research and Academic Staff at the School of Civil Engineering, Faculty of Engineering, University Teknologi Malaysia, to give an opening speech. Professor Dr. Khalida, over to you.
Okay, Assalamualaikum warahmatullah. Thank you very much, Dr. Amirul. And salam sejahtera to all. Alhamdulillah, today we are able to meet again, eventually, even though we only meet through virtual platform, but Alhamdulillah, we managed to continue our activities. And this time is on SKA Shine sharing sessions. I could say it's 2.0 for this year, right? Okay, first of all, I would like to thank to Dr.Nor Eliza Alias and also Dr. Kugilavani as our speaker for this second SKA sessions. And also thank you to Dr. Amirul as the host for this event today. Okay, as we all know that SKA sessions for this year is a meeting, as mentioned by our host just now. It's a meeting between the youngsters in SKA. All right. For this time is the second SKA sharing sessions, and hopefully we will have many more of these sessions to be shared by our youngster from SKA. Okay, as we all know, before this, most of the topic that been discussed in the first series of SKA sharing sessions were more on the experience among the lecturers on their academia career. As far as I can remember, among the lecturers, there are only a few of the lecturers in the SKA Shine that discussed their research interests. Okay. Others mainly shared their experience and issue related to the academia world. However, it is all a very good and interesting sharing session given by our SKA Shine members. However, for this SKA Shine sharing session 2.0, I would like to strongly encourage to all the SKA Shine's members to present or share their own niche research area. Okay, while we are emphasizing to you all share your research activities or research area, mainly for several reasons, which I can mention here. One, you can use this platform to inform others about your research focus, your research interest to all of your friends and colleagues, okay? And maybe from your finding, it's going to be a very beneficial information to others that maybe have a similar research area or different area but need input from your research, okay? This is also can be one of the platform to increase your visibility through your research activities. But most importantly, what I can see here, by sharing your research activities, you will be able to increase the potential collaborations among the colleagues within your within SKA or outside from SKA. So this will make it easier for you to create a research team, okay, and collaborators, which later you will be able to work together in securing research grants that maybe require interdisciplinary research fields. So hopefully from such good connections and networking that you have, you'll be able to conduct and produce more impactful output from your research activities, which later on will be benefited to the faculty, to the universities, and also to the community. Okay, so hopefully after this, all of you will be able to share your experience, your research experience and your results that you have obtained from your research activities. And for the new staffs that have just recently joined us as the SKA members, you can even start by sharing your finding from your PhD thesis. Yeah? So lastly, I would like to express my appreciation to both of our speakers today, and also to Dr. Amirul as the host for today's sessions, and also including to the organizing team that work behind the screen, which is Puan Izzat and also Puan Shima, and also IT technical teams. I guess that is all from me. Hopefully everybody will benefit from this sharing sessions. Thank you very much. Back to you, Dr. Amirul.
Thank you very much, Prof. Dr. Farida, for an interesting opening speech. Okay. So basically today, this afternoon, we have two speakers from the Department of Water and Environmental Engineering, our school, Civil Engineering. Before I proceed with the introduction for both speakers, I just want to let you know if you have any questions regarding the topic that will be discussed or present during the session, please write your question through the chat box so that I can pick up the session and bring back for the speaker to answer based on your question after they finish their presentation before we end up this afternoon session. Okay, that's the important point that I want to mention here. Okay, now I would like to introduce our first speaker. Our first speaker is Dr.Nor Eliza binti Alias. She is a senior lecturer at the Department of Water and Environmental Engineering, School of Civil Engineering, Faculty of Engineering, UTM. She is also a research fellow at the Center for Environmental Sustainability and Water Security. We know it as IPASA in UTM. Besides, she is also a group leader for the eco-hydrology research in UTM. Okay, and the title of the lecture that she will be talking about this afternoon is the Climate Change Impact Study, Why and How. Okay, without further ado, I would like to invite Dr. Eliza for her lecture this afternoon. Dr. Eliza, over to you.
Okay, thank you very much, Dr. Amirul. First of all, I will not say that this is a lecture, but just a sharing session on the topic that I think is relevant and that I want to have more collaboration with. So that is why I chose the topic regarding on this climate change impact study, specifically on why and how, and not so much on the results, but more to why it is important and how we can do this kind of study. Okay, and this morning, actually, Prof. Sobri also did another talk related to this topic, which is very similar, but of course, he is a professor and well established and a lot of information. So my my case is just on the introduction to especially those who are new to climate change idea. Okay, so for example, we can see here I forgot to say some thank you for this opportunity, and also Prof Halida and Dr. Amirul. Okay, so move on to the topic of climate change. So usually if we here climate change, or another term that is usually used is global warming. And this kind of picture, if you can see my slide, right? So we can see here global warming, destruction of the planet Earth and everything. Okay, so what does this means actually, and why does this climate change or global warming term become, how it appear to us, and how why it is important, and how do we conduct this kind of climate change impact study. Okay, before that, just as Dr. Amirul introduced, I'm from the Eco-Hydrology Research Group, and there are a lot of research group in UTM, and specifically in our School of Civil Engineering. Some are usually correlated. This, for my case, is I'm in the group of the Eco-Hydrology Research Group. Okay, and also from the Center for Environmental Sustainability and Water Security, besides being in the School of Civil Engineering. Okay, another, I think for us who are already used to the word climate change, and when we hear Donald J. Trump, maybe some of you might have his opinion as well. The most for us interesting comment is from him is it's freezing in New York. Where the hell is global warming? Okay, so people might understand that global warming means warming, such as the picture that I showed you before. It's freezing, it's cold. Why are people saying it's global warming? Okay, and these are all actually questions that I think most of you are thinking, for the people who are new to this climate change or global warming term. And this kind of questions is actually not wrong, because if you don't understand what actually is occurring, or what is the impact, then you might think this kind of way, just like Donald Trump. Okay, so what is global warming actually? It is also referred to as climate change. It's the observed century scale rise in the average temperature of the Earth climate system and its related effect. In dictionary, global warming means, I mean, this is the term in the dictionary, what global warming means. Okay, why does it say that observed from a century scale? By records, based on the, maybe like this, for example, this is taken from the IPCC 2007. IPCC is one of the platform for interpanel of climate change. It is a platform of various institutions and bodies, and which are related to this climate change impact study. Okay, so if you can see here, this scale shows that you can see here the time before 2005, 10,000 before 2005. So it is thousands of years before our current condition. Okay, so this is usually used to explain why we are saying the climate change, and why is there a global warming. For example, this is not temperature, but a proxy of the temperature is the greenhouse gases. This greenhouse gas. We may, I mean, scientists have already collected thousands of years of data before. Okay, and you might think how. So I will show you later how do they collect this kind of data. But the most important thing here, for example, we can see carbon dioxide, methane, nitrous oxide. So these are all greenhouse gases. So greenhouse gases are related to temperature and global warming. So if we see this year, 0 year, means 2005, we can see that the gases content of the concentration are extremely high. If we based on data, proxy data from thousands of years before. So this shows that there is something different in our era, in our century. Okay, so how do they get this data? So they get this data actually from ice cores, because ice cores, they have some trapped bubbles. They scientists can take that trapped bubbles and collect or estimate the content of these greenhouse gases. Okay, so again, these are the gases, the concentration are a proxy to measure the temperature. It's a proxy to show what has been changed and what are the changes. Okay, so these are, for example, where do we get the scientists get those information? So it is from this kind of experiment from ice cores. Okay, and we need to know this that, for example, these records are gathered and taken from NASA and the NOAA, and National Oceanographic Association, I think. And so these are actually the temperature. And before it's a proxy, just the gases, which can be hindsight thousands of years before. But for temperature data, okay, and we can see here for this y-axis, this is the global temperature anomaly. So anomaly actually means the average of a certain century. So 0 means the average. Where's my mouse? Okay, so 0, this means the deviation from the average in this century. For example, this data is from 1880 until 2010. It's about 1800s and then 1900s. So this shows the changes in these centuries, where the trend is actually changed from before 1940. Okay, the temperature is below the anomalies and below the averages. But as we go on after 1940, okay, and actually 1940 is the industrial era, in the industrial ages. So this is when the greenhouse gases started to coming up. So after that, after the 1940s, the temperature are shown to be higher than the anomalies. So this shows that due to human activities, this greenhouse gases increases. So that's why the temperature also increase. In this case, these are the anomalies. The temperature against the mean temperature against the averages in a certain century. Okay, so the question is, what actually changes? Why do we call it climate change? What actually changes? So according to IPCC, again, changes are on the variability of weather and frequency of extremes. This will generally have more impact than changes in the mean climate at a particular location. So in climate perspective, for example, the most simple is either temperature or rainfall. So what is being said here is the changes in the variability and the frequency of extreme instead of the mean. This means that let's say we have annual rainfall, total annual rainfall, or the average annual rainfall. So annual rainfall means the total rainfall in a year. Okay, so if we if we take the rainfall data every year, the total rainfall data in a year, and we study that data, we analyze that data. So each year there might not be so much difference. The total rainfall from 1970 until 2000 might not have that much different. But if we look at the extreme events, for example, the highest 1-day rainfall in a year, the highest 1-day rainfall in a year. So we look at that data each year from 1970 until 2000. So we may find there is some significant changes. So that's what this means. The changes in the variability of weather and the frequency of extremes. So climate change impact is usually that way in the extremes and not really on the averages. So that is why when we see a picture like this, you may guess this. I'm sure a lot of you knows this is in Kelantan in 2014. Okay, it is an extreme event. For example, during that event, there is this some climatic system which we call Madden-Julian oscillation. MJO, and it escalate the condition. If it's wet, it becomes wetter. If it's dry, it becomes drier. And there are also many other climate system like where La Nina, El Nino. So all of these are related to climate change. So it is actually a climatic system. So in 2014, there exists this Madden-Junior oscillation system, and at the same time, there is a really low temperature below anomalies at the Siberian high. So Siberian high is near Russia, in Russia. Okay, so if you understand the concept of monsoon occur when there is some different pressure in the atmosphere, in the temperature. So when there is a really high temperature at our upper hemisphere here, like the Siberian high, it will move the winds and create some monsoon. When there is some high pressure at the upper hemisphere and low pressure at the lower hemisphere. So these monsoons developed based on that, based on climate, based on the climate, the temperature. Okay, so during this time, 2014, there is a recorded really low temperature below anomalies. Again, anomalies means below the normal values. So the monsoons was really intense, hence bringing a lot of water to Kelantan, our east coast. Okay, so we might say, is it climate change or not? And there are also other events in Malaysia which keeps exceeding the historical values. For example, in 2015 in Sabah and Sarawak, and the rainfall historical records exceeded. And particularly for Sabah and Sarawak, usually the rain are from typhoon, the tail of typhoon. So typhoon is actually related to the changes in climate. So I will show you later. And also in Penang, for flood, torrential rain lasting for hours and strong winds. And also 2018, 2017, 2018, the flood in Johor, Terengganu, Pahang, and Sabah. So this is from the monsoon season, which repeated. But again, some stations recorded exceeded historical rainfall. So the rainfall are being exceeded every year, and we can say that the historical values are exceeded and becoming near, keep on exceeding and exceeding. Okay, so issues of climate change in Malaysia are well aware of, and a lot of institutions like the Department of Irrigation and Drainage, the National Hydraulic Research Institute in Malaysia, the Ministry of Science Technology, Ministry of Environment, all are aware of this, and there are a lot of measures or programs which they are doing currently. Okay, so again, besides rainfall, another obvious observation is from typhoon or cyclones. And the word typhoon or cyclones is actually, typhoon is, the Japanese call it typhoon, the US call it cyclones, but it is actually the same thing, the same climate thing. So because of climate change, tropical cyclones are expected to increase in intensity. Okay, and because of that, have increased rainfall intensity and have larger storm surges. But there might be fewer of them globally. So again, in terms of extreme, the intensity might be higher, but the frequency might be lower. Okay, so these changes are driven by rising sea temperatures and increased maximum water vapor content of the atmosphere as the air heats up. Okay, so these are also some proof of the intensity of the cyclone is increased. So here on the y-axis is the accumulated cyclone energy index. So this ACE is it represents the intensity and duration and the how long the cyclones occur, the duration of the cyclone. So the occurrence and the number of occurrence again of high intensity and long duration cyclones are observed to increase. For example, in this graph, which is produced by the IPCC 2007. Okay, and also across the ocean, the ocean system. For example, we see the West North Pacific. There is increase in the index of the cyclone intensity, and then also in the East North Pacific, North Atlantic, we cannot really see distinguish pattern, but in West North Pacific and East North Pacific, we can see this impact of climate change. So where is actually West North Pacific, East North Pacific? So East North Pacific, okay, this is the Pacific Ocean and the North Pacific Ocean. This is the South Pacific Ocean. Can you see my mouse?
Yes.
Bye. Okay. So this is North Pacific Ocean, South Pacific Ocean, East, West. So US, usually they call it a cyclone, I think. We call it typhoon. The Japanese call it typhoon. So in the East North Pacific, this is the pattern which they experience and recorded higher index of the typhoon. And also to the West North Pacific. This is actually near to us, West North Pacific. The typhoons that occur at West North Pacific actually influence us, Malaysia. Because this, the tail of these typhoons usually may reach, especially Sabah and Sarawak. And okay, and also from the North India and South India. So we can see that the pattern are really high in the East North and West North Pacific. West North Pacific is directly influenced to us in Malaysia. Okay, so what happened when increase in rainfall, increase in typhoon, changes in the variability of the temperature, and then the frequency of number of rainy days, number of dry days. So all of these actually increase the risk. This existing risk will amplify for the natural and human system. So climate change will amplify this existing risk. Okay, so who's watching? Who is managing or organizing? What are the impact? What we can do? All those kind. So definitely not this Trump, and he is also not here anymore. Not as the president of the United States. So who is watching is the Intergovernmental Panel on Climate Change. So IPCC. So this IPCC which I keep referring to. So this Intergovernmental Panel on Climate Change, it is owned by the World Meteorological Organization and the United Nations Environment Program. Okay, so they are the one who chairs working groups by various scientists in the world, including us, Malaysia. So there are some working group on scientific basis, on impacts, vulnerability, adaptation, on mitigation, and also task forces for on national greenhouse gases inventories. Okay, so what do we do? So do we go to the future like this person? So what we can do is we can observe the future and we can model the climate and see what is the expected impact. Okay, so how do we do that? So there is this global climate model or general circulation model. Okay, so I will share a bit on the what is GCM, the development, the scenarios used, and what the most important is this downscaling and bias correction in order for us to use the data. Okay, the output of climate models are basically climate data, rainfall, temperature, solar radiation, humidity, wind velocity, and many more, and several more. All the climate data. Okay, so the purpose of this model is actually, yes, to numerically simulate and project future climate data as a result of changes in some boundary conditions. So what does some boundary condition means? It is particularly on the greenhouse gases, the concentration of the greenhouse gases, which is produced by us human. Okay, GCM can project much longer for 10 or 100 years and long enough to learn about the climate in a statistical sense, in this means and variability. The model does not, we might not believe exactly 1 January to 2090, that is the rainfall. It does not work like that. And GCM model, it just produce the we may use the statistics and the statistics of that model output data. Okay, so there are several type of GCM, atmospheric GCM, ocean GCM, and also some coupled AOGCM. Okay, again, this is, if you just Google GCM, you will see this picture. Okay, so it is actually a model of the whole planet, there are two important things. It models the spatially and temporally. Spatially means according to grid. So each grid like 60 kilometers, 60 kilometers. So what is the climate data? And then another way is the temporal. Does it model monthly, daily, hourly, minutes? These are the outputs of the, this is the process and the tools for future climate data. So we model it using GCM. And a part of that, if we look zoom more smaller or finer, the GCM also have some, we call it parameterization, where it models a specific physical process such as convection of the rainfall, not rainfall, of the climate system. In this case, the convection of how the rainfall becomes and appear and produced. So, okay. Okay, so again, GCM models, there is not one GCM model, there are a lot of GCM models. So these are the input and the change and input is this is the boundary, the greenhouse gases. So depending on this concentration of these greenhouse gases, so what is the output of the climate, the projected climate data. For example, here this is not the recent. The recent is in the SWIP 6, but this is previously we use this RCP. So for example, RCP 2.6 is if we project a lower concentration of greenhouse gas. If it's RCP 8.5 means that we introduce more higher concentration of greenhouse gases. Okay, so the development of this GCM were since the 1970s. So the difference is according to the spatial resolution and also the component that it used to model the climate. So this is FRR means first assessment report, second assessment report, and third assessment report. So this assessment report are reports produced by the IPCC. Okay, so this another example where the components of the climate model, as we go along until today, a lot more physical components are being inserted into the model. Okay, so what else? Okay, so these are the scenarios. So the scenarios represents the concentration of the greenhouse gases introduced into the model. Okay. How long do I have, Dr. Amiri?
So basically, 7 more minutes.
7 more minutes. Okay. So these are the example of the scenarios. It changes. It changes according to a different assessment report by the IPCC. Okay, so like I showed you before is the RCP. So for example, RCP 2.6 says that one pathway were radiating frozen peaks at approximately before 2100 and then decline. So these are all, for example, the concentration of the greenhouse gases being introduced. For example, 8.5, one high pathway for which radiative forcing reaches continues to rise for some amount of time, assuming constant emission after 2100 and constant concentration after 2250. So this RCP shows describe different greenhouse gases inclusion into the model. And the most recent is the short socio-economic pathway. So I think because of the complication in defining this, I think they make it more simple to understand. For example, if a country has sustainability taking the green road is doing that, those countries is doing that, so they may use this scenario, the SSP1 scenario, okay, to see their climate change impact in the future. Okay, and for example, if this country is in the middle of the road and there are some measures are being done to reduce these greenhouse gases, some maybe half and half, so then they may choose middle of the road. And so on. So these are all the representative on different scenarios which we choose. We as the scientists or researcher who wants to conduct the study, so we choose which scenario that we want to represent our condition. So usually we just take the worst case scenario. For example, SSP5, fossil fuel development taking the highway. So we take the worst case scenario. There are no measures are being done to reduce our greenhouse gases. Okay, again, there are more than 30 GCMs actually. So who manages this? So this SMIP what coupled model intercomparison project. So they manage and collected all the GCM's outputs from various countries and institution or organization or centers. So they collect them all so that the people, us, can use those data. Okay, so for us researcher, we may just take that data. We cannot model the GCM by ourselves. It will take a lot of time and high resources of money and time. So what we can do is just we take the data from, for example, this SMIP and this CMIP platform. Okay, so also SMIP also is like the IPCC report. It's by phases. It is by phases. It is released by phases. So as we go until now, the most recent is the SMIP 6. The current data that we can use for our climate change impact study. Okay, so why is there a lot of GCM data? So which one we can use? So if we combine all the GCM data, for example, these are just some. There are some variability, a variation of the output. In this case, the output is just the temperature. So there are variation of this climate output. So because why? Because there are, of course, there are uncertainties. This is just model. So what usually scientists do is they use several GCM model which fits their country, which is proven statistically to fit their country or current climate condition. Then they choose which GCM models are most suitable. However, these SMIP, spatial and temporal, are usually between 60 kilometer to 100 kilometer, or the temporal resolution is really high, daily or monthly, for example. For climate change impact basin scale study, we need final spatial and temporal resolution in order to conduct some modeling. We need at least the resolution of hourly climate temporal data and less than 20 kilometers spatial resolution. So that is why there is some method for downscaling. So this downscaling has dynamical and statistical downscaling, which we can do it ourselves, or okay, downscaling and bias correction. So both of these are really important for us to use which climate change model output data suitable for us. So this two we need to do in order to conduct some climate change impact study at a local scale. Okay, so by doing downscaling, it becomes a regional climate model. For example, here we refine the resolution, spatial resolution, and also the temporal resolution of that model output. Then we can use it for some climate change impact study at a local scale. For example, these are the Japanese climate model from 20 kilometer. For Japanese climate model, this is actually quite fine for a GCM. Usual GCM is 60 to 100 kilometer temporal resolution. But for the Japanese, they have this 20 kilometer model of the whole planet. The resolution is 20 kilometer. So they have this RCM 5 and 2. And for Malaysia, we may use this. Japan has the Southeast Asia, 5 kilometer. So this is actually included in the Codex. The one if you heard Prof. Sobri's talk, the Codex under Prof. Tangang. So this is actually included in that Codex program. Okay, so why it is important? Okay, because the scale is important for us to model, for us to represent the outputs of the climate data. For example, if it's 20 kilometer, Japan is here, so we might not capture this kind of a more finer typhoon occurrence. If you look at this one, the 20 kilometer, it may not capture this more finer intensity of the rainfall due to typhoon. Okay, so RCM we may get it from Cordex, and even our National Hydraulic Research Institute Malaysia, it has its RCM as well, which we can use. So if you are interested and you don't know how to do downscaling really well, you can get the downscaled the RCM data from NAHREM or from Cordex, which is already in the spatial resolution of 6 kilometer or 5 kilometer. And also NAHREM or the National Hydraulic Research Institute Malaysia also have this web system. I think you need to log in for this, but you can contact NAHREM if you are interested in this system.
Dr. Eliza, that's very
Yes.
interesting. Talking about that GCM model whatsoever. So basically, yeah, that's great. So
Okay.
basically, yeah,
Can I wrap?
yes.
I need to wrap up, right? Okay.
Yep, please.
Okay. So, going maybe 1 minute. So we have the projected future climate data. So what we can do? So we can do it for any climate impact study. And remember, we have to choose the right model. We need to do some bias correction. If local scale, like here, local analysis. For local analysis, we need to downscale and get the RCM. If just for comparison, we may use the GCM, which has a larger spatial resolution. So what impact study we can do is basically any climate induced disaster research. For example, we can couple this into a hydrological model. Just use the input data from the GCM or RCM, downscaled GCM or RCM data into our hydrological models. So for me particularly, in the process of doing some several case study in the river basin in Malaysia, And besides flood, actually other things we can do also, like a fire hazard map, using historical climate data, and then we have the model for fire hazard map, risk model, and then we can use future climate data for future hazard risk map. And this also be the same for, let's say, landslide, disaster risk map for landslide, which is actually indirectly is from the rainfall data and the intensity of the rainfall. So there are a lot of more research that we can do actually. So these are some of my PhD students. Most of the students are we try to put in the climate change idea into the research. Okay, so I think that's all for me. Thank you very much.
Thank you very much, Dr. Eliza, for the very interesting presentation.